Let us go to the second problem. Second problem is like this. I have a piece of chalk, I am trying to break it. As you can see, there is this index finger at the very extremes, one here and one here. The other two fingers, the thumb 1 and 2, left and right, are in between these two index fingers. Okay. So, when I apply the load by rotating my set of fingers, this is going to break, right. So, let us say we want to find the scenario of what is exactly happening to this piece of chalk. So, in order to do that, we want to draw the free body diagram. Okay. So, let us just draw first the piece of chalk, locate what are the forces of interaction. One of the forces of interaction is mg, right. We can decide later whether this is going to be a predominant force or not in the calculation for which we want to find out the breaking forces necessary. Okay. As you can see, in this particular case, you are trying to rotate one finger about the other. Can you recognize that? You are trying to rotate one finger about the other and therefore, there is one load, okay, with some friction in it, and another load over here acting due to this right hand, and similarly there is one load over here, another load over here acting to the left of this piece of chalk. Typically when we apply like this, there is one force that is being pressed here and equal and opposite force is applied on the other, because this particular body, the hand, is in equilibrium, only these two are moving, okay. And therefore, I can for all practical purposes assume that I have applied F1 and F1 over here, F2 and F2 over here. There could be a small frictional force present, but this frictional force may not be as much as the distance the distance between these two set of forces may not be as much as the distance between these two set of forces. Okay. Ideally, I should have drawn like this. Let us say this is F2, this is F1, and that completes the free body diagram. If you notice, the mass of this particular body is not that much important while breaking it, and therefore, for all practical purposes I can even remove those forces that do not contribute much. Also observe that this friction, even if it is a very, let us say frictionless surface that I have on this piece of chalk, it should be possible for me to break, right. Or in other words, these forces F1 and F1 that small f1 and small f1 that I have drawn are not that big compared to these two set of forces, and therefore, for all practical purposes, even if I draw something like this, it should be perfectly okay. This completes second.